What's important here is that once some or other new innovation happens, what you will find, and I would like to stress this point, is that you can unlock additional value by standardizing. So once you do discover some new innovation, you say, wow, that's really cool, we can do this and this and this. The moment you bring standardization into that, it actually unlocks additional value. And the reason for that is a few things. One of them is just reuse. The moment you standardize on something, someone else can reuse that. Okay? And if he's standardized, you can reuse his stuff. So you can reuse his tools. Okay, and that allows you to bring in components off the shelf. So you can take something that's already been built and you can reuse that as well. So there's just a whole lot of value that gets unlocked by the fact that you're starting to standardize and use these standards in your systems. So just after, you'll find that whenever something that has been innovated is getting effectively used, there will be some standardization around it, and either it will be a de facto standard as something like a shapefile or something, or there will actually be some big standards body that will come in. And so always remember that, if you're thinking about in your proposals or something, put a little bit of money aside for the idea of making sure that this stuff's going to get standardized, because it'll unlock value for you in the future as well. The other thing that we've seen is that you need to have two distinct architectures. So when you're thinking about that in your proposal, if you're planning on taking the system to an operational system at some point, realize that you're going to have these two architectures. You're not going to be able to build one system that's going to solve all the problems, the research problems and the operational information system problem. You're going to have those two architectures in place, these two separate systems. They will use certain components, and the standards will help with that. There'll be a lot of reuse, but they're definitely going to have to be these two systems. Service-oriented architectures can help solve the access problem in both cases, and that's quite important. So just by getting the sort of services in place and stuff like that, that will really help with the access problem. And we saw that was sort of right at the back of both of those process chains. We had discovery access, and we had access into process and analytics. So access right at the back, and the service-oriented stuff can really help there. And there's a need for workflows, not necessarily scientific workflows, but you will need either some sort of processing chains in your operational information systems, or you're going to need the value of something like scientific workflows inside your research space. And that's to capture provenance and repeatability and stuff like that. And in a operational information system, by having those process changes, it allows you to adapt the system, to expand it, to integrate it with other systems. Some further things that we have learned. PostGIS, very effective. Spatial and time series, relational database management system, something very worthwhile using. So if you're thinking of storing your data in a relational database, a little bit of effort goes into setting it up, but it's definitely worth it. It's going to allow you to query and subset your data in a very effective way. If you're going the NetCDF route, make sure you go CF1. It's OGC. It's actually in the process of becoming an OGC standard as well. So there's a lot of effort, and it just means that there's so much tooling that suddenly becomes available to you the moment you make it CF1. And I know it's the climate forecasters or something like that one. So it was actually initially thought out for the climate change community. But a lot of the standardization inside there is applicable to many other EO domains. Then OpenDAP makes all your NetCDF stuff service-oriented architecture. Okay, and that's very important. So when I talk about the fact that you want to go towards service-oriented architectures, and you're thinking about, okay, I've got all this NetCDF data, OpenDAP brings that out onto the web, and that adds a lot of value. So if you want to bring your data out onto the web, think about doing OpenDAP as opposed to putting it behind an FTP website, FTP site or something like that. It also allows for subsetting and a lot of that kind of stuff, so it's very, very valuable there. SensorWeb is very good for sparse in-situ time series, we find. And what's quite nice over here, I think it's probably one of the most mature OGC standards in terms of SensorWeb's one of the most mature area domains is actually water, because there's the whole water ML, which is actually a profile for water-related time series. So it really sort of tightens the space around water and creates a common taxonomies, and so I think there's a lot of thinking has gone into it as well. So it's very valuable, and it actually shows that SensorWeb can be applied quite effectively there. And then web feature services, coverage service, map services, stuff that you might be familiar with. These are good for snapshots through time, but not very effective with time when I'm saying basically giving you a spatial view, but they're not good for time series. So when you want that snapshot, a sort of a time series of data, we find that they're not as effective. You usually have to switch to something like a OpenDAP or something like a SOS, a SensorWeb standard. Okay, so scientific workflows can help you with your big data problems. We've seen this in other domains. I won't belabor those points because it's been spoken about here before, but it allows you to move your analytics to your data, so you can move your actual processes around. And we're seeing things like Wolfram already doing that, and we're seeing stuff like MATLAB allowing you to move your processing to one of their cloud computing resources to do it over there. And if you've got the data sitting at something like the CHPC, you'll be able to move your processing to that data, rather than trying to move these masses of data around. And then also it allows you to orchestrate distributed processes. If you're using a lot of computers to do something, and especially in our case, as the sort of science gets bigger and bigger, you want to be able to orchestrate that and control that and distribute across these processes. Important there, understand your use case. It dictates a lot about how you format your data and how it's going to be stored. And then obviously combining PostGIS with NetCDF can bring ad hoc queries to data cubes. There's a lot of value to be gained over there. So bringing these technologies together, using them together, there's value to be unlocked as well. So if you're thinking about a system, put a PostGIS, NetCDFs, put some OpenDAP on the front over there, you're going to gain a lot of value in your community. Okay, and the standards are going to help a lot as well, because other people's tooling will be able to connect to it. So back to those conclusions. No silver bullets. Understand your eventual use case. Use standards extensively, and we've seen cases like this recently. Within very short amount of time, we've been able to roll out completely different systems just by the fact that they're using the same standard-based components at the bottom. So just because we standardized on the ground, we didn't have to go and rewrite stuff. We just put the layers on top of each other. And then there's lots of components off the shelf over there. So if you're thinking about, if someone's trying to sell you some Uber system, there's a lot of open source stuff out there. You don't have to go and buy their new product from Europe or something like that. If you guys want to put a system out there, you can just go in and look at the open source stuff and the components that are out there and use those. Thank you.